Satellite imagery are being collected over Earth at all instances in time, at all locations. These include images of wildfires, urban expansion, ecosystem change, and much more. However, a fundamental challenge remains. Earth is changing continuously over time and space. So, how can we really teach AI models to understand this changing behavior of Earth? How can we build foundation models that understand how Earth changes through space and time? This has been the core of my PhD research at KTH Royal Institute of Technology. My first contribution was a model called Noise to Map. Diffusion models were initially developed for image generation, and they showed very strong potential in that. So we asked a question: can we use diffusion models for downstream discriminative tasks? And the answer is yes. We developed a diffusion model called Noise to Map that solves semantic segmentation and change detection and achieves state of the art performance on multiple datasets versus several other state of the art models. Building on this, we investigate geospatial foundation models. These are large pre trained models of millions of images over Earth. The promise is that they can generalize to to different conditions and domain shifts, such as changes through space and time. We develop and integrate a diffusion decoder based on the first model, which is noise to map, and integrate this decoder to the foundation model's encoders. And then we show that using our decoder, these geospatial foundation models become much more strong and resilient in the application of wildfires. We furthermore investigated efficient adaptation, in which we ask how can we efficiently adapt these large foundation models instead of retraining all these millions of parameters to some downstream tasks, such as wildfires. And we show that low rank adaptation, which is updating less than 1% of the parameters, is the strongest way to do that. And then I explore a further, more fundamental question, which is that Earth is a sphere, and satellite imagery come with particular features, which are coordinates that are not available in natural imagery. And I ask, how can we embed these satellite images in a way that respects distances on Earth? And we come up with a new self-supervised learning method called GeoDistill that does that and outperforms other foundation models on different tasks. Finally, I developed a dataset called S2 Tandem for Fire, which is a global wildfire dataset for minute scale temporal resolution. All these contributions to try to solve the problem, which is how can we teach AI to understand our Earth in a changing environment.